It's 05 or 07, so we can start. So first of all, welcome again to the second day of the conference. And once more, I would like to thank our sponsor, Bergy Wind Power, to help us supporting this event and helping making it free for everyone. And I will say it also later, but just so that you know, we have decided to have a conference next year, and that will take place the 20th and the 21st of September, so that we have the dates fixed. But without stealing more time to the first speaker, so our first speaker is Professor Antonio Pantano from the University of Palermo in Italy. He has a big experience abroad and a big research interest in composites, mechanical design, and wind turbines. And he will tell us about the telescopic tower. And then, yeah, he will try to introduce also a little extra topic, which was not planned originally. But then, yeah, if we get more questions and we don't have the time enough, we can take it a little later as well. So, Professor Pantano.
Okay, thank you, Daniele. I will share my screen. Okay. Okay, can you see my screen?
Yes.
Oh. Okay. I will talk about a telescopic tower for wind energy production. We have built this telescopic tower a few years ago with funding from a research project. So the research project was called Palermo. It's an Italian name. It's like telescopic tower for the production, for the wind energy production with reduced environmental impact, but it was written in Italian. So mainly it was designed from zero, from scratch, construction and field testing on an auto-lifting telescopic wind tower of about 30 meters. We will see how it works. In the end, we were able to rise and lower the tower, or using a control on there where it was installed, or automatically responding to some particular condition, or by remote control. As we will see, so we will using in the case of a wind turbine with two blades, we are able to take the height of the tower to the floor and then rise to 30 meters whenever we want. And so there was nothing, however, on these topics. There was nothing. There were on the market. There are on the market small telescopic pole for like 10 meters long for usually other function or for small, very small wind turbine. And we will see. So mainly there are the deeper masts, so masts that are one piece and they are horizontal on the ground when they are low, and then you use a hydraulic piston and you rise the mast, but it's not a very robust solution and cannot be very long because the bending moment and the bending stress are very high at the base. Then, as I say, there are hydropneumatic telescopic masts that are short, so they are not very robust. Usually, they are like an old car antenna. If you remember, they were in in the 80s. And in our case, the Perima project, so it's very stable, robust, and the time for rising the tower is short enough. You can see in already in the bottom, we will see again. So we go from this position to, this is a person, so it's this is 30 meters, 31 to be precise. And now we will see what the advantages are. The main drawbacks of when you have many, you have a wind farm, so many wind turbines, the environmental impact is a problem, and then there are possible risks for fauna, there's noise, and also if there are very strong wind, like a hurricane or something, the turbine can be damaged. So the Perima project proposed to design this new telescopic tower, and for wind turbine from 60 to 250 kilowatt, and obviously the height of the propeller can be around 30 meters in this case, but this can be scaled up, not to 100 meters, but for sure can be made bigger. So there are mainly 4 parts: foundation, a telescopic tower, a self-lifting system, and a generator that has been bought. But to optimize the lowering of the turbine, it should be 2 blades. Otherwise, we would need like another hole here. If we have the 3 blades, we can make all under here for one of the blade. So what can be the uses? What are the advantages of this solution? Well, first of all, it can be used in areas where tourists are present, like in summer, for example, and maybe they don't like to see, like a small island, for example. We have many in Italy, in Sicily in particular. I am from Palermo, and so maybe they don't like to see this wind turbine in the landscape. So we can lower this during summer, or in summer during night, for example. So a second mode could be to operate the tower only at night. This can, in the case we don't want this, again, this impact, visual impact. We can lower the turbine when there is little wind, for example, okay, and the production would be at 0, almost 0. So there can be, there could be a sensor. If there's enough wind, it will stay up, otherwise can go down. And as I say, we can use nighttime, or we can do maintenance ground level, and if there is like a typhoon, we can drop immediately the tower. Here we can see a bigger picture. We will see a video immediately after. Okay, I will go out of the presentation just to show the video with the higher resolution. You can see that the tower is rising. The speed, obviously, as you can see, the structure is about 10 tons, the weight, and can rise other 10 tons for as weight of the wind turbine. Has been installed at Caltanissetta, Italy, and so the system is working fine. Yeah, a few details about so the project, the design, very quick, but so you can find everything in this paper that has been published. I don't know why it's so slow. Okay, well, you can ask about this paper and exactly what you can find is the International Journal of Precision Engineering and Manufacturing Green Technology. There is all we will see. Okay. So there are 3 masts of 3 different diameter. There is a coupling system that allows for the sliding, and there is an internal thrust piston that will take the turbine from ground level to the final height. And we will see other image. Okay, here we can see that we need to create a house in the ground for the mast and for the thrust piston. So we have 2 different holes. One is larger and another smaller for the thrust piston, and then lifting system will be here. Well, we will understand better this in a moment, but so there are mainly these coupling sleeves, okay? And these coupling sleeves allow when so the piston take all the tower up, so there will be friction. There are conic conic areas at the end of the internal sleeve and inside the external sleeves. So this will create friction and locking, and but there are also, we'll see, some plates with Teflon, okay, that will allow the sliding without having movement, okay. Here you can see the Teflon plates, so it is, to be precise, outside is steel, and inside we have the Teflon plates, okay. They are not structural, they just reduce the friction in the sliding, and we must be able to adjust the internal diameter of the sleeves, because there must be when these tower are created, the poles, they are not perfectly, when the diameter is large, like 1 meter, 2 meter, they are not perfectly round. So you need to adjust, you need to adjust the position of this place after you insert the other mast, so that you will have the correct fitting near the external sleeve and the internal sleeve. This is the truss piston. It's made of 3 parts that are connected. They are connected here, okay? And we can see these holes. These holes are needed for the lifting system. That is a jack-up system, but we have to. So we have seen this kind of system in the oil rigs. There are some platforms that they are for like oil extraction or other kind of oil inspection, but they are rather different for different use. So we have to. The idea is the same, but we have to rearrange a little design from zero again. The lifting system, an image of the lifting system. It will take the pole up 1 meter and then fix, insert some pin, so the tower will not, the piston will not go down, and meanwhile the hydraulic piston can go down again and push again up another meter the structure. Here are the materials, mainly steel, everywhere with tape from what? Okay, we made a few, obviously a few calculations for the to verify the mechanical resistance of the structure, and we designed to resist up to 97 kilometers per hour or 27 meters per second of wind. And before using the Teflon plates, we tried the rollers. But this design with rollers, again, we need to be able to adjust the position. The design with rollers was causing at the base, so in the place with the higher forces applied from the wind, tension that were too high, okay, stress concentration. So this design didn't work. There was no way to make this design to work, even making the roller larger. So we came up with the design with Teflon, and you can see we have Teflon and the support. In this case, on the pole, the stress was very limited, and there was no problem. Well, other calculation on you can find in the paper, and also we had to do a calculation on the pins that are holding the pole in the position, in the final position, and also during the jack-up. We also need to decouple in terms of rotation the piston from the towers, because the piston cannot rotate because there are the pin inside. And we came, and also we needed a tensioning system to take the free mast in traction, and we used an air spring. with the coupled with this system, the rotation between the piston and the tower, and also with the air spring, we keep everything in the right tension, the right, so that the coupling, the telescopic coupling will work correctly. So in conclusion, we have designed from the scratch this telescopic tower, and there could be many advantages. Obviously, the tower is more expensive than a normal tower, and we are available. I mean, if there are anybody interested in this technology, there are companies in this research project where also Italian companies that can work again to produce other pole if there is a request. So this concludes my presentation, and I just want very quickly to show you a video of my wind turbine for I was very long on this presentation. I have invented, patented a small wind turbine. Also have a startup called Happy Wonders. I will show you a video, and that's it. You will understand immediately. It's a Savonius type wind turbine, but with this particular way of working. So the blades against wind will close, and since you can do also with fabric, the blades, it can be in any inexpensive solution. With there are several advantages, and well, the idea looks interesting, but we need funding to develop the idea to a higher level, and that's it. Okay. There are also possibility of making like an hybrid turbine with the combination of the new turbine and the conventional Dario turbine. Okay.
Thank you very much. I can see that there are some comments here. Fritz, do you want to unmute yourself and ask your questions?
I have some questions.
Yeah.
Okay. I have some experience with telescopic antenna towers for the emergency units for the Red Cross. And we encountered some problems with, if it's hydraulic, with leakage of oil, because there are a lot of substances in the oil that cause environmental issues. And with the towers we had on air, we had problems over time with leakage from the ceilings. So this is you use hydraulic, and then you can also use water as a medium.
Well, as you have seen in this case with the jack-up system, so there are two small hydraulic pistons that's been avoided. It's not like other solution in which the oil is filling the entire tower. So if you want, I can show you again the jack-up system. But this piston is like I don't know, 20 centimeters in diameter or 30, and they don't leak. They don't leak, and they are strong enough, to rise very high loads. Well, we are studying also a solution in which the piston is pushed up by water, but so the piston has like a ceiling, okay, that is taking and also like kind of a system that is will take the water from the lower part, so the of the hole to the upper part and vice versa, so that you will push up or down the piston, and the piston then will take up the tower. And in this case, you don't care too much about the leakage, because it's like a closed system. The entire hole is filled with water, and you simply move this water with respect to the base of the piston, where there will be a ceiling with something that will move the fluid from one part to the other.
Okay, thank you.
Any more questions?
Yes.
Yeah, we have one from the physical audience here.
Okay.
Yeah. You want to come here?
Price-wise, difference between fixed towers and telescopic towers.
Could you hear the difference in price between the telescopic and the fixed towers? If you have done any studies on that?
And the fixed tower?
Yeah.
Well, there are many studies on the fixed tower. We didn't care too much. So we started looking at a similar tower, so a tower that was 30 meters tall, and we had all the calculation about this tower, and so we took this as starting point, you know, for the like the thickness of the walls and this kind of stuff, but everything else really needed to be calculated from zero. I'm a professor of mechanical design, so I was able to.
The question was if price-wise or cost-wise.
Price-wise. Okay. Price-wise is much more expensive. So we obviously can try to reduce the cost in a new attempt, but for sure it's much more expensive, because also you have to make this all in the land, and this is also expensive. Something that is easier is the setup, because you will have to take 3 10-meter pieces to the place, to the installation, instead of a 30-meter tower. But for sure it's like 3 or 4 times more expensive.
Then do you have some kind of safety in terms of hydraulics or so? I mean, if something fails, how to block it, let's say?
From falling?
Yeah, in general, like as a security system for not unfolding itself when...
Well, this was a prototype, and so we didn't include like break the money were finished. So, but for sure, like an elevator, we can install something simple that eventually will stop the tower from falling. If you have to consider where the pins that go in the holes in the piston. So once they are in, and they are designed to withstand the weight of the. So there is a safety also number. They can hold much more in terms of weight. So they will never go out because of friction, unless you rise first. You rise the tower a little, and so the hydraulic piston must be activated. Rise a little the pin that are on the bottom using the pins that are on the top. And so this is something that cannot easily happen without the system working.
Okay. So yeah, I would like to thank you for now. And if the audience have some more questions, can they just get in contact with you? That's I mean, the address is on the article. Then we could also share the article if it's open access, or if not, give the link to the article.
I don't know.
No, but we can always give the link to the article, and then people can find out themselves.
Yes. I don't know if now it's open. I have to check.
Yeah, but the address, at least it's available there, so then that shouldn't be a problem. Yeah, so thank you very much for the presentation.